Hello everyone. Today we are going to solve problem container with most water. In this video, I will first explain the intuition behind the problem. Then we derive two-pointer approach step by step and understand why moving a particular pointer is correct here. After that, I will write a Java code and we will analyze its time complexity and space complexity. So let's start by understanding the problem first. So the problem saying we are given an integer array height of length n where there are n verticals line drawn such that endpoint of ith line are like this. Okay, what we have to do? We have to find two lines that together x-axis from a container such that the container contain the most water. The requirement is we have to return the amount of water a container can store, maximum amount of water. Okay, so let's understand this by analyzing this problem. So the problem saying we are given a height array where each element of this array representing height of bar. Here, one representing the height of this bar, its height like this. So the problem requirement is we have to find a container which can contain the maximum water. So how can we do this? In this problem, they have said how can we form a container? We can form a container by two vertical lines and by two heights, and the width will be the difference between these two bars. Okay, so we have to find such container we can store the maximum. So very brute force approach that coming to our mind is we can use two nested for loop and find uh, all the possible container and select one that giving us the maximum area. Yeah, that is correct, and that will work too. Time complexity is n square. If my height array is long, in that case n square is quite big, will give big time complexity. So we have optimized our algorithm. We have find an algorithm, a solution that could run in linear times. We do this, understand this. Let's come here and analyze how can we build such algorithm which run in linear time. So here this is the height array, and what we have to find two bar which together with the x-axis from a container. So basically, the requirement is we have to maximize the area of the container so that we can contain the maximum water in that container. So what is, how do we calculate the area of a container? So the formula of the area is like this: height into width. Here, height, what will be the height and width? Height will be the minimum height among both. Why so? Let's come here and see what we need. We need height so that we need a container which can contain maximum water. If I choose among, let's take this example. If I take this container where the first bar is this, second bar is this, and this is the base. So here, which height you will consider for the area? Maximum one or minimum one? Of course, minimum, because if I take the maximum, I can't store my water till this length because the other bar is shorter than this. If I consider this height, in that case, my water start overflowing. I don't want that. So in that case, I can only store water till the minimum height. This making sense, obviously. Yeah, so to find the height of a container, I will consider the minimum height among both bar. And what will be the base of this container? The base is the difference between both bar. If my first bar at index 1 and second bar at index 8, in that case my base will be the difference between them, which is 7. 8 minus 1 will give me 7. So in that case, what will be my area? I will choose the minimum height. In that case, one bar height is 8 and other bar height is 7. So I will choose the minimum one, 7, and the base is 7. In that case, I am getting area 49. 7 into 7 give me 49. So till now, what we have understood, we have to maximize the area depends on these two variables, my height and width, and my area directly proportional to this value. So in that case, if my height is maximum, my area will be maximum. If my width is maximum, my area is maximum. So both are contributing to area, and so we have to try to maximize height and width so to get the maximum area. Why? So take this example. If I only try to maximize height only, let's say my there is such container where let's imagine its bar height is 10 and its bar height is 9, which is maximum here. So in that case, what will be the what height I will consider the minimum one? I will consider the 9. Okay, so 9 my is height, and what is base here? In that case, my base is 1 because they are one. Why so? Because let this height at index 6 and this height at index 7. So in that case, my base is 1. So what will be the area if my height is 9 but base is very low, which is 1. In that case, I only get area 9, which is very small. So here we have understood here width is also matter and the height is also matter, because let's take this example. Here the width is maximum. Here the element first bar is at very beginning and the last bar is at the last. In that case, my base is 8 here, but what is height I will choose? I will choose the minimum height. In that case, it will be 1. So height is 1 but base is 8. Again my area is 8 only, which is again less. So I need to balance both. I need maximum width as well as maximum height. So what's how can we do that? Maintain the maximum width. What I can do, I will start searching for the first bar from the very start, and I start searching for the second bar from the very last, so that I find two bar which is very uh, far from each other, which give me the maximum width. But also we have to try to maximize the height as well. So first we have understood I must need two pointer where I will place my one pointer at this point, at let's say at very beginning, and other pointer at very end. So yeah, so we understood why we need two pointer, because we have to find two bars, and we also need to maintain the maximum width. For that I will start from very far from each other. If I start L from here and R from here, in that case, it won't work. Okay, so we have understood two pointer intuition, why I need two pointer and why they start from like this. Now understand, I need maximum height as well. If my first height is at 1, which is very low, in that case, it gives me a minimum area. So I need to search the maximum height. So what I can do, I will try to I will move from here to here for the search of maximum height, so that I can get the maximum height. In that case, what happened? Here my first bar of is of height 8 and second bar is height of 7. In that case, the minimum is 7 and the base is also larger. In that case, I got the maximum area. What I can do, I will move the pointer which is pointing to minimum height, so that I can maximize my height. Again, at that point, what I can do, I will see which is minimum, which pointer pointing to minimum height, and I will move that pointer for search of better height, so that I can maximize my height. So here we have understood which pointer I should move. Which one? The minimum one, of course. To maximize the height, I will always move the pointer which is pointing to minimum for the search of better height. So in that case, I will move my R pointer for the better height. I am hopeful that in future I got the maximum height. For that, I will move inward. I will move R pointer. So we have understood two things. First, I need to start with two pointer, and I should keep both pointer far from each other. And I will which pointer I will move? I will move the pointer which is pointing to minimum height, so that I can find the maximum height in future to maximize the height. This is the intuition of this problem. Okay, so and to find the maximum area, I will keep track the area of each at each point. At for this number, I will track the area. For this point, I again track the area and return the maximum area wherever I found that. So this is the whole idea. So how I will write my algorithm? I will start with two pointer, and by placing both pointer at the boundary of the array. And what I will do, I will first calculate the area. How can I calculate the area? Here, what will be my height? Height will be the minimum between both. And what will be my width? Width will be the difference between them. Here, if my first bar at index 0 and last bar at index 8, in that case, the width will be the difference between them. Okay, and simply I will multiply them and got the area, and I will keep track the maximum area uh, for every point and return the maximum area wherever I would found that. When I will stop moving when both pointing to same element or cross each other. For example, at this point here it can still form a container. The first bar will be this, and second bar will be this, and width will be 1. What happen if both come to same pointer, both pointer pointing to same element? In that case, I can't form any container, and if they cross, means we have check all the container. So this is the idea. I will keep moving my pointer until they don't cross each other. Let's come here and write code, so that we understand how to write code. For that, what I need two pointer. First, I need a left pointer which start from 0, and other will start from very last. So for that, I will take the length of the height array, length, length, okay, -1. And what I need a maximum variable so that I can track the maximum area. For that, I need a max variable. Let's call it max area. It will track the maximum area. Start with 0. And I will run a while loop. How long? Until L and R not, not close to each other. And what I will do, in that case, first I need to calculate the area. How can I calculate area? For area, I need height and width. How can what will be my height? Height will be the minimum of both bar, between both bars. So it will be minimum, whatever the height of left bar and height of right bar, which is the minimum. I will consider that height. And what will be my width? Width is nothing but the difference between both. So L minus R. Okay, this is how I can calculate my area. And what I need to track the maximum area. For that, what I can do, I can write like this, something like this, math dot max, and it will take the maximum area, whatever the maximum, max area and area. Okay, now what I need to do, I have to move pointer. Which pointer I will move? For that, I will check the condition. Whichever pointer pointing to lower height, I will move that pointer. For example, if my left pointer is larger, let's call it L, and my right pointer pointing to lower height, in that case, what I can do, I will move my R pointer so that R can find someone which, so that my R can find a better height in future. So I will move it inward. So I need to move 1 1. Otherwise, I will move left pointer. If my left pointer is not larger than right pointer, in that case, this if block will not work. So I will come to this block. That means my L is pointing to lower. So this is how I can write the logic, and at last I can return the max area. So this is simply I can return max area. Okay, this is the whole logic, now idea of the algorithm. Let's run and see whether it's working or not. Okay, this working. Let's submit it as well so that we can see it's applicable for all test cases or not. Yeah, it's giving us quite average time complexity. This is the standard uh, algorithm for this problem, two-pointer approach, and it's working. So let's analyze its time complexity and space complexity. So here time complexity is linear. Why? Because I am iterating over this height array only once. From left I am iterating, and from right I am iterating. So every time I no, I am using element each element only once. In that case, I am running only one while loop. In that case, my time complexity is simply linear. And what is my space complexity? So space complexity is also constant. Why so? Because here I am not taking any extra array or anything. Here I am just using this three variable which takes only constant space. Variable takes constant space. So in that case, my space complexity is constant and my time complexity is linear. Hope so you like the explanation. If so, please consider to like and subscribe my channel.